Hey guys, how you doing? Adam's Apple here, and today we're going to be doing a cool new Let's Play series of TinkerCAD. Let's play, let's build. This is going to be super cool, brand new series. I hope it's going to go amazing. Yeah, that seems like a pretty cool little thing I made right here with a flashing LED. And yeah, I'll see you guys then in the next one.
Okay, so I just did a few updates, and yeah, we're working on kind of a cooler system right here with the new light setup. Got a nice kind of wave going on here with the new pattern. So yeah, wow, look at that. Oh my god, it's absolutely gorgeous.
Okay guys, so I did some work here off camera, and we just made our very own custom LED light strip right here. Really nice fade effect. Look at this, just going all around town.
Yeah, so I didn't want to show you guys all the boring stuff, but then I also went ahead and worked on the Jacques Cartier bridge. We made another big fade effect. I think the city's gonna love this one. Oh, okay, and then I reinvested the profits from that into a massive worldwide rainbow LED. Okay, hello, Adam here. In today's video, we're doing a little bit of a physics experiment here. Hello, teacher's name that I won't say. So we're gonna be working here with some Arduinos, these cute little boards. We got one physically right here, plugged in, as you can see by the blue USB cable there. Anyways, with the actual experiment, what we're going to be making is a blinking LED. One of the hardest things ever to make. It's a very complex invention. It's crazy they came up with this thing. Without further ado, we have all these gorgeous parts here we're going to slowly come to figure out as we do this new Let's Play series, but today we're starting out with just the LED. So you're going to put your boy up there, and then you're going to go ahead and grab a resistor. But just to start with, already you see with the LED you have your cathode and anode. Cathode is going to be the negative terminal, the V low, and the anode is going to be the positive terminal, or as you call it, V high. It's very high up there in the rankings. Now that you have basically your LED right there, we're going to be going ahead and hooking it up onto the board. But you might say, Adam, where do you want to hook this up on the board? Well, you see you have these digital outputs, analog ones, and power. We want to go ahead and put them onto these digital outputs, so this way we can control it with pretty simple usage. You wouldn't want to put it on analog. This is not going to be controlled with an analog signal. Obviously, it's just going to be pretty much a yes, you're turned on, or no, you're turned off. So we're going to basically go ahead. The wire functionality is kind of built in really easy, so you can just click and drag wherever you want. Yeah, see, I can make these beautiful. First, I'm going to also make sure I don't forget to mention the resistor, right? So now, okay, I'm going to put the resistor on the side. What I could do is be stupid, be ooga booga caveman brain, plug this LED directly into the board, give it the full power, and let's just see what happens. Oh, look at that. Beautiful. Wow, very bright LED, isn't it? What's that? It's telling me I shouldn't do that? The current through the LED is 48 milliamps, while recommended maximum is 20 milliamps. The usable lifetime of the LED may be reduced. Oh, Lord heavens, that's horrible. We're gonna burn out a virtual LED. The point is, what I'm trying to get at, is that this LED right here will die if you keep giving it the full power of the board from pin 13 with all its glory. So we're gonna get out of here, we're gonna unplug that, and we're gonna go ahead and stick in a resistor. Put them into place right here, and we're just gonna hook them right up. Terminal 1 there to pin 13 for power. Terminal 2 then to the anode. So this is kind of like V high. It gets turned down a little bit, and it goes through the LED, and to V low, then it goes right to ground. Now with this resistor right here, you can, instead of putting it to kilo ohms, you can put it to something like around 100 ohms, as the kind lady in the video, Becky Stern, said in the Arduino video. You want to set this guy to around 100 to 1,000 ohms. So we're gonna put it up like that. Yeah, and then basically now when we go ahead and run it, there we go. There's no more error. It's not complaining. It's not screaming. We're not killing the LED, and it's just gonna blink. And now, okay, so of course, sorry, I was about to sit down and just think the video was over. It isn't. Now we got the fun part with the code. Look at this. So if you can do something called reading, the code blocks are pretty cool because you can see what they do. Wait, stop blinking. Thank you. So let's say that none of this is constructed yet. How do I, yes, get out of here. Out of here. Be gone. Die. Perfect. Okay, so now, to start everything off, we're going to set this bad boy to high. And there should be some kind of notation for waiting here as well. Okay, that's good. And what we're going to be doing is setting the LED to high, to low, and then to high. High is basically just the notation Arduino uses for turning a light on or turning it off. So look at this. So we're going to have, well, first of all, we're going to put a control now to wait 1 second. See, so we just drag the block and it fits right in like a glove. After waiting 1 second, we're going to fit in right like a glove right there. Another one to go to low. It's going to turn off the LED. It's going to wait a second. And then it's going to go loop back around. It's kind of implied in the code, right? That once it's done this last wait and it's like, oh, what do I do next? I go all the way back up to the top. And you're starting again with the LED being set to high. Now, if I run the simulation, boom, you see it's turning on. The LED is flashing. It's going to high. It's kind of implied in the code, right? That once it's done this last wait and it's like, oh, what do I do next? I go all the way back up to the top. And you're starting again with the LED being set to high. Now, if I run the simulation, boom, you see it's turning on. The LED is flashing, it's going to high. Waiting 1 second, low, 1 second, coming back up to the top. See, it kind of goes around and loops in a circle. As you can see, there's also different little features on the board, such as the yellow L pin right there, which is just used for testing out the timings and stuff like that. Of course, now, if you want to move on from the block codes to actual text, so these are the two key parts at the start. You can see, if you kind of like read the code from left to right and look at what are the important parameters, you have this section and this section, with this part of the code being the void. As I like to call it, the void of constant repetition, or the void of, like this one, or the void of setting up. Basically, at the start of the device, it sets this pin to be an output. So it just says, hey, wake up, pin 13, you're going to be set as an output pin. And then after it's done that setup, it doesn't come back to this. It then moves on to the loop section. And the loop section right here is what it does infinitely, where it goes, first of all, goes to digital write 13. Digital write is just a function for writing to the different digital outputs here. You're going to write to digital 13 and write to it, hey, pin 13, you're going to be high now. You're going to be turned on. So it's going to be our V high. It's going to send power then through the resistor, through the LED. Then it's going to wait on a delay of 1,000 milliseconds, as you can see in just the little comments right here, the dash dash. Then after that 1,000 milliseconds of it being turned on, it's then going to digital write again to the pin 13, set it to low. And then it's finally going to wait another 1,000 milliseconds until it goes, of course, right back to the top of the void loop. And it does this void loop infinitely. As I like to say, it's in the infinite void of just doing the same thing constantly over and over and over again. And yeah, that basically kind of concludes the cool little showcase here of the Arduino Uno. I may or may not turn this into a Let's Play series of screwing around in TinkerCAD, and hopefully these videos will not be so boring in the future, and we'll have more lights to mess around with. Thank you.